This is a very beautiful number theory problem. Here if 3 to the power 2002 plus 7 to the power 2002 plus 2002 is divided by 29, then find the remainder of this division. This is a very beautiful number theory problem. Here if 3 to the power 2002 plus 7 to the power 2002 plus 2002 is divided by 29, then find the remainder of this division. Before the solution of this problem, we have to know some definitions and theorem on number theory. At first, we discuss about the congruent modulo. What is congruent modulo? For AB belongs to the set of integers, n belongs to set of natural number, then A is congruent to B modulo n when n divides A minus B. This is the definition of congruent modulo. A is congruent to B modulo n when n divides A minus B. That is, A minus B is divisible by n. This is, and also it can be written as A equal to n cube plus r. These are equivalent. A is congruent to B modulo n is equivalent to A equal to n cube plus r. Here Q is the quotient. Q is the quotient. R is the remainder. Sorry, n is the remainder. Here also remainder is B. B is the remainder. Remainder here is B. B is the remainder. N cube plus B. A is congruent to B modulo n means A equal to n cube plus B. You can see that A minus B is multiple of n. Some multiple of n. So we can say that A minus B is divisible by n. And these are two equivalent. A is congruent to B modulo n and also A equal to n cube plus B. This is the division algorithm. And also we have to know the Fermat's little theorem. Fermat's little theorem. Fermat's little theorem states that A belongs to set of natural number, set of integers. A belongs to set of integers. P is prime and also A P. GCD of AP, that is GCD of AP, greatest common divisor AP is 1, then A to the power P minus 1 equal to 1 modulo P. This is the statement of Fermat's little theorem. Fermat's little theorem states that if A belongs to the set of integers, P is prime and GCD of A and P is 1, then A to the power P minus 1 equal to 1 modulo P. This is the Fermat's little theorem. Also we have to know some properties of congruent modulo. Properties of congruent modulo. First property is if A equal to B modulo n, C equal to D modulo n, then first property is AC equal to BD modulo n. This implies. Second implication is A plus C equivalent to B plus D modulo n. A plus C equivalent to B plus D modulo n. These are the properties, theorems and definition with the help of this we can solve this problem. With the help of this theorem and definitions we can solve this problem. And now we write now 3 to the power 2002 plus 7 to the power 2002 plus 2002 here. This is divided by 29. If this is divided by 29, then we have to determine the remainder. Now 3 to the power 2002 can be written as 3 to the power 29 minus 1 to the power 71, 3 to the power 14. This can be written as 3 to the power 2002 equal to 3 to the power 29 minus 1 to the power 71 into 3 to the power 14. Now we can apply Fermat's theorem on this, that is 3 to the power 29, 3 to the power 29 minus 1 is equal to 1 is equivalent to 1 modulo n, that is congruent to 1 modulo 29. This is Fermat's theorem. To the power 71 into 3 to the power 14. 3 to the power 14 can be written as 3 to the power 3 to the power 4 into 3 square. This is equal to we have already known this property, that is if A is congruent to B modulo n, C is congruent to D modulo n, then AC equal to BD modulo n. Here also we can write 1 modulo 29 into 1 modulo 29 equal to 1 into 1 modulo 29, that is 1 square modulo 29. So this is 1 to the power 71 modulo 29. So this is equivalent to 1 to the power 71 modulo 29, 3 to the power 3 to the power 4 3 square. This is equal to 1 modulo 29. This is 27 to the power 4 into 3 square. This is equivalent to 1 modulo 29 and 27 to the power 4. 27 is equivalent to minus 2 modulo n modulo 29 to the power 4 3 square. This is equal to 1 modulo 29 minus 2 to the power 27 is congruent to minus 2 modulo 29, because if we divide 27 by 29, then remainder will be minus 2, that is 27 minus 29 is divisible by minus 2. So we can write 27 equal to minus 2 modulo 29, that is remainder of this division is minus 2. So this can be written. So minus 2 to the power 4 equal to 16 into 16 modulo 29 into 9. This is equal to 1 modulo 29, 16 modulo 29 equal to 16 into 1 from this property, that is 16 into 1 modulo 29 into 144. 16 modulo 29. This is minus 1 modulo 29, because if 144, that is 144 is divided by 29, then we can find the remainder as minus 1. Minus 1 is the remainder. So 144 is equivalent to minus 1 modulo 29. These are equivalent. So this is equal to sorry, this is not 16, because 16 1 into 16 into 9 is 144. So this is 1 modulo 29, this is 1 modulo 29. That is equal to minus 1 equivalent to minus 1 modulo 29. This is, so we have got 3 to the power 2002 is congruent to 3002. 3 to the power 2002 is congruent to minus 1 modulo 29. In similar way, we can find the 7 to the power 2002, which can be written also 7 to the power 29 minus 1 to the power 71 into 7 to the power 14. This can be written as this, that is 7 to the power 2002 is equal to 7 to the power 29 minus 1 to the power 71 into 7 to the power 14. Here also we can apply the Fermat's-Little theorem, because 7 to the power 29 minus 1 is 1 modulo congruent to 1 modulo 29. This is 1 modulo 29 to the power 71, 7 to the power 14. This is equal to, from the property we can write 1 to the power 71 modulo 29, 7 to the power 14 can be written as 7 to the power 3, 7 to the power 3 to the power 4 into 7 to the power 2 into 7 to the power 2. That is equivalent to, also this is equivalent to, that is congruent to 1 modulo 29, 7 to the power 3, that is 343. If we divide 343 by 29, we get remainder, that is 29, 343, 29, 53, 29, 58 minus 5. Remainder is got as minus 5. If we divide 7 to the power 3, that is 343, that is 343 by 29, we get the remainder as minus 5. So this is equivalent to minus 5 modulo 29 to the power 4 into 49. This is equal to 1 modulo 29, 625 modulo 29, 49. This is equal to, congruent to, this is equivalent to 6 to 5 modulo 29, 49 multiplied by 49. this is congruent to 625. 625, this can be written as 25 multiplied by 25 modulo 29, 49. 25 is congruent to minus 4 modulo 29, because if 25 is divided by 29, then we get the remainder as minus 4. That is, this is congruent to minus 4 modulo 29. This is also minus 4 modulo 29. Modulo 29. 49 is also congruent to 49 is congruent to minus 9. That is minus 9 modulo 29. If 49 is divided by 29, then remainder is got as minus 9. This is. So this is equal to minus 4 minus 4 minus 9 is minus 144. Minus 144 equivalent to modulo 29. This is equivalent to minus 144 modulo 29. We can write this by the property of congruent modulo. So this is also equal to congruent to plus 1. 144 is minus 1. So minus 1 into minus, that is plus 1 modulo 29. This is equivalent to 1 modulo 29. 29, that is equivalent to 1 modulo 29. Now lastly we have 2002. 2002 is congruent to modulo 29. What is the remainder? If we divide 2002, that is 2002 by 29, this is 174, and here 9, 1. The remainder is 1. If we divide 2002 by 29, we get remainder as 1. That is 1 modulo 29. Here 2002 is equivalent to 1 modulo 29. Now finally this number, that is 3 to the power, finally 3 to the power 2002 plus 7 to the 3 to the power 2002, 7 to the power 2002 plus 2002 is congruent to 3002 is congruent to minus 1 modulo 29. We have already got this. 3 to the power 2002 is congruent to minus 1 modulo 29. Minus 1 modulo 29. And also we have got 7 to the power 2002 is congruent to 7 to the power 2002 is congruent to 1 modulo 29. That is 1 modulo 29. And also 2002 is congruent to 1 modulo 29. That is 1 modulo 29. These are cancelled out, so ultimately we get 1 modulo 29 congruent to 1 modulo 29. So 3002 is congruent to 1 modulo 29. So the remainder of this division is 1. So the remainder, so the required remainder, so the required remainder of this division is 1. We have got ultimate remainder is 1 for this division. If we divide 3 to the power 2002 plus 7 to the power 2002 plus 2002 is divided by 29, then we have got the remainder as 1. This is the final remainder of this division. This is the remainder, and this remainder is 1.